Hi everybody, good afternoon. So today I will do the presentation here. So the title of our presentation is System Cost Reduction with Vincotec 3-phase ANPFC power modules for grid-connected converters such as chargers, heat pumps, and UPS applications. I am Tiago Jappe, and I'm a product marketing manager in Vincotec. So let's start with the agenda. And this presentation will focus in three-phase PFC converters. So target these solutions for high-efficiency power conversion systems. So this is the main target of this application, because we will focus just in three-phase solutions. It's part of our agenda, our revisions between solutions in 2-level and 3-level topologies that have been used for the PFC converters. And after that, I will show you some power module solutions that are oriented for applications such chargers, heat pumps, and UPS. And in the end, we will summarize the key points of the presentation, and that is focused for three-phase PFC converters, demonstrating what kind of solutions Vincotec has for these systems. When we see the trends and the figure of merits used in order to design a PFC converter, we see that there are several figures of merits. In this case, we can see here in the picture that are these different figures of merits. We can see, for example, we evaluate losses, how is the cost involved in order to design a power converter, how is the complexity, what is the final volume, the weight, and so on. So there are different figures used in order to judge if it is this design, if this power converter it's a good implementation or not. Of course, depending on applications, always these different figure of merits, they have different weights, but there is a general approach that the designers use it in order to judge if the PFC converter or any power converters is a good implementation or not. Here we define it, what does a PFC rectifier, what does it mean? So this is just a key definition, right? That we define that one PFC rectifier is a converter that is able to synthesize sinusoidal mains current, and also that this converter is able to do the regulation of the DC output voltage. So this is the definition that we have from one PFC rectifier. And what kind of specifications that generally are applied for these three-phase PFC rectifiers is required that the low current, the mains current, should have a lower harmonic distortion, generally below 5%. So this is a key requirement that we have for PFC rectifiers. And we have also the power converter should have and should be compliant with the EMI regulations and these standards, right? And in this presentation here, we will demonstrate the solutions in power modules that we have that for applications that require three-phase input connections, such as heat pumps, EV chargers, and UPSs. Doing a revision, so revisiting the PFC converters concept. I'm talking just about the three-phase implementations. So we can see that we have implementations based on 2-level converters, and we have implementations based in 3-level converters. You can see here that I'm talking any topology. I don't define any topology yet, but I'm just evaluating based on the behavior of these power converters, between a difference between a 2-level and a 3-level converter. And the waveforms that I'm showing you here is that one 2-level converter, as we know, the switched voltage that is in this point in here, in this connection, what is the voltage that this converter synthesized is switched voltage, that is in gray color here, that is between plus and minus half of the DC link. This is the instantaneous voltage that we can measure if you put a probe in this point here, and you will be able to see the waveform in gray color. And this gray color, so this has the switching frequency here, and the fundamental component is demonstrated here in the blue waveform. If we analyze the harmonic spectrum of this waveform, we are able to see this behavior, so that we have just a fundamental component that is in the blue color, and after that, the next component that we will find for a two-level converter is just in the switching frequency. So let's put some numbers. If the frequency of the grid is 50 hertz, you will be able to see the spectral harmonic of this instantaneous voltage. You just see the fundamental component, 50 hertz. And if I'm switching, like, for example, 10 kilohertz, the next frequency that you see in the spectrum is just 10 kilohertz. But if you analyze and do the measurement for a three-level converter, as I mentioned, doesn't matter what kind of topology here. I'm just talking if it is a two-level or a three-level. I didn't define which is the topology here, not yet. And for example, so returning for the three-level converters, you are able to see the voltage measured in these points. This voltage will have three levels. That is between plus and 0, and after that between 0 and minus half of the DC link. So this is the instantaneous voltage that one three-level converter is able to synthesize. But if I analyze the harmonic spectrum of this waveform, the instantaneous voltage synthesized by the converter, I can see that we will not have high frequency components at the switching frequency, but actually we will have in the double of the switching frequency. This is the main characteristic that we have when we compare a two-level and a three-level converter. Giving some numbers, for example, if in both cases I'm switching in 10 kilohertz, in this three-level converter, I will not see any component in 10 kilohertz. I will be able to see the harmonics in 20 kilohertz, in the double of the switching frequency. And based on that, we can see that we will impact directly in the size of these inductors here. So taking as reference same specifications of ripple current, same inductor material core and operation conditions, we see that the three-level inductor used for a three-level PFC will be half of the size. And if we considering that the cost of the inductor is proportional, directly proportional with the volume, we can see that we are saving money here because we have half of the price just in passive elements, right? So let's analyze now, because we saw that three-level converters have very nice benefits impacting in the reduction of the passives. Let's see what kind of topology is able to work in three-level operation. And in this case, here we have the ANPFC converter, the ANPFC, and the symmetrical PFC boost converter. These are different topologies. Here I'm showing just the drawing for one phase. And if I compare which the topologies is more interested and more cost effective, I can evaluate based on which semiconductor that is used to assemble these different topologies here. There's the key description of these topologies here, but I would like to highlight you here that this ANPFC converter. Why? I will tell you that this device, this power topology here, employs just 650 volts, for example, and so these components for 650, they have much more lower switching losses, and comparing to one other topology that employs 1200 volts devices. So for example, this ANPFC, these diodes are rated for 1200, and here for the ANPFC, these devices are rated just for 650 volts. And now, analyzing the difference of these different converters, we can benchmark and analyze the cost and the efficiency that each converter can give me. So in this first graph, here we have the two-level. In blue color is the efficiency versus switching frequency. So we can see the two-level converters is a six-pack. Two-level converters is much more interesting, has a high efficiency for low switching frequency, but after 60 kilohertz, it's started to be lower efficiency comparing to the other topologies. Why? Is because here in low switching frequencies, just a majority are conduction losses, and after 60 kilohertz, the majority of the losses start to be the switching. Here we have, for 1 point in 40 kilohertz, for example, we analyze the difference between these three different topologies, and we see that in blue color are the conduction losses, and in orange are the switching losses. Because of using 650 volts devices, in three-level topologies, we see that the contribution of switching losses is much more lower. Why? Because the 150 volts has lower switching losses coefficients. And now, analyzing these different topologies concerning the efficiency and the cost, we can see that this three-level converter, ANPFC, has a good balance regarding cost, in orange color, and efficiency. So this is one topology that has a good trade-off and the equilibrated trade-off concerning cost and efficiency. What kind of solutions that Vincotec has available in power modules for three-phase applications? Here I'm showing that we have a huge portfolio of products for different housings, and as well we have for different topologies. So we have this flow 0, flow 1, and flow 2 are the name of these housings, and we have implementation for all these different topologies in different levels of implementation. For example, we have one power module that is just for one phase, and we have as well solutions that is the three-phase topology is everything integrated just in one power module. Returning for this ANPFC and how is this topology is assembled, right? This is based on this NPFC converter. So the NPFC, we know that these diodes should be rated for 1200 volts, but if we move this diode for the center of this bidirectional switch, so instead of this diode, move it from here, so we can rate all these devices for 600 volts. And in this case, using just 650 volts, we are using devices that has a lower switching losses, so it's expected to have much more high efficiency. So we are adding value considering a three-level topology, plus, on top of that, using just 650 volts devices that they have, in the end, much more high efficiency. Here I'm showing you some examples of power module solutions that Vincotec has in the portfolio that is starting from 15 amps up to 100 amps. So we have, for example, one power module for just one phase in this housing. And we have, for example, the complete three-phase system as well inside in just one housing. Here, both products are rated for 100 amps applications. Here is the one product that has been a new product that have been launched here for PCIM that is addressed for heat pumps applications up to 4.5 kilowatts. That is an integrated solution that we have we have both the first stage, the active front-end PFC converter, plus the inverter. So this is the topology that we have been using. Everything is inside of this housing, Flow 1 housing, that is addressed for heat pumps applications. This is very nice product and very interesting because it's very cost effective because you can use the 3-level topology in the input stage, so you are saving money concerning the passives, and you are also using just 650 volts devices that you are as well have lower switching losses, adding a lot of benefits for your product. So in order to summarize the key points of the presentation, so I highlighted here some key benefits of the 3-level converters that are effective, cost-competitive solutions comparing to the 2-level components, because we can save cost and save money in elements like passives, and you also have a lower volume and lower height for the final system. And this the 3-level converter plus 650 volts devices give me the key benefits of high efficiency system. So Vincotech has a huge portfolio of different power modules, and we have solutions that have been used in this topology that has been addressed for high efficiency systems like heat pumps, EV chargers, and UPSs. So that's it. If you have any question, you can visit us in the booth number 7, and also you can access our website in order to see more details about these products. Thank you very much.